So in the first part, the first video from this lesson, we talked about how trigonometric ratios and trigonometry actually are related to similar triangles. Any two triangles having corresponding pair of congruent acute angles are similar. So if they're right, they always have the right angle similar in this case, or congruent. In this case here, it's showing A is congruent to angle X. And the part that we base our trig ratios on is the fact that corresponding sides have the same ratio. So we mentioned these definitions. The sine of an angle is the opposite leg over the hypotenuse. And often I'll say just opposite instead of opposite leg, but remember we said that's S. Let's highlight these S, O, H. That was so. That helped us remember what sine was. Cosine, that's the adjacent leg over the hypotenuse. And that was C, A, H, so ca. And then tangent is the opposite leg over the adjacent leg. And we remember T-O-A, so TOA. So ca TOA is a helpful way to remember that. So know that sine is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, and tangent is opposite leg over adjacent leg. So this says state the exact values and decimal approximations, and we're going to go to 4 decimal places, which is 10,000ths, for sine, cosine, and tangent of angle A. All right, so we're looking at angle A because opposite and adjacent are in with respect to a certain angle. So we want sine of A. So we abbreviate that just with SIN. Sine of A is going to be opposite. So we're going to look up here at our definitions. Opposite leg. So here's angle A. Opposite leg is 5 over the hypotenuse, which is 9. So there's the exact value. The decimal approximation, we want to go ahead and divide 5 divided by 9. So 5 divided by 9 is 0.5 continuing, but we want to go to 4 decimal places, so 0.555, and it would round up to 6. So there's sine of A. Make this smaller so we can see what we have here. Cosine of A. Cosine of A is adjacent over hypotenuse. Well, here's the adjacent, but we don't have a length there. Well, we have 2 sides of a right triangle, so we can find the third side. This is usually called B, lowercase b, because it's across from angle B. So we can say 5 squared plus b squared, the other leg squared, equals 9 squared. This is 25 plus b squared equals 81. Subtract 25 from both sides, so 81 minus 25 is 56. B squared equals 56. Take the square root of both sides. Normally we would put plus or minus, but this is a length, so it has to be positive. And this can be simplified into the square root of 4 times the square root of 14, which is 2 root 14. And I know not all of you are up on that, so if you need to for now, you can leave it as square root of 56. But now we know B is 2 root 14. Two times the square root of 14. And so over here, now we can find cosine. Cosine is that adjacent leg, which is 2 root 14, over the hypotenuse, which is 9. That's our exact value. And the decimal approximation, we can go ahead and put that in the calculator. 2 times the square root of 14. And then we can divide that by 9. And we get 0.8315 because we would round up. And then tangent, finally, the exact value is opposite leg. So we're looking at definition of tangent, opposite leg, which is 5 over the adjacent leg, which is 2 root 14. So this is the exact answer. It's not the proper form. So if you remember from algebra, you should multiply top and bottom by the square root of 14. For right now, I would accept this answer, but we have 5 root 14 over 2 times 14, which is 28. There's the exact value of tangent of A, which I wrote that incorrectly. I should have had A there. And we can find that, so 5 times the square root of 14 divided by 28 would be 0.6682. So we found the exact values and the decimal approximations for sine, cosine, and tangent of A. We did have to use Pythagorean theorem to find the missing side. All right, let's look at this next one. I don't know if we can. Given acute angle A such that cosine of A is 3/5, find sine of A and tangent of A. Well, we might not even have this triangle to start with, so I'm going to cross this out. What we want an acute angle, and remember, figures aren't always drawn correctly, but we want a acute angle. This is A. It's an acute angle. So the cosine of A is 3 over 5. Well, going back to our definition, the cosine would need to be adjacent leg over hypotenuse. So the adjacent leg we could write as 3, and the hypotenuse could be 5. That was just a ratio, but it will still help us find the other ratios. And so in order to find sine of A, by definition, sine is opposite leg over hypotenuse. Well, we want this leg over here, which we don't have, but we could name it, and we could find it using Pythagorean theorem. X squared plus 3 squared equals 5 squared. You might recognize this as a Pythagorean triple. Subtract 9 from both sides, which is 16. X has to equal 4, so we found what x is, so sine is 4 over 5. Opposite leg over hypotenuse, and then we can also find tangent of A. Tangent is opposite leg, which we just figured out was 4, over adjacent leg, which is 3. To finish this lesson, well, not quite finish it, but we do want to discuss, and I'm going to go ahead and go back just to this program, trig ratios of some of our special angles that we've talked about earlier. We've talked about a 45, 45, 90, and we discussed the relationships there, where we have 1, 1, 1, and root 2 as our side lengths. They'll always be in that ratio. And then we started, over in this 30, 60, 90, we started with an equilateral triangle and figured out some relationships there. So for 30, 45, and 60-degree angles, we can find exactly what sine, cosine, and tangent are. So let's take a quick look at these. Sine of 45. So here's a 45-degree angle, and actually so is this one. But sine of 45 is opposite leg over the hypotenuse. Now, again, we're not supposed to leave them like this, so we learned we can multiply by root 2 over root 2 to get that this is root 2 over 2. So the sine of 45 is square root of 2 over 2. The cosine of 45. Cosine of 45 is adjacent leg over the hypotenuse. Oh, it's the exact same thing. So it's root 2 over 2. And then tangent of 45. This is a good one and an important one. Tangent of 45 is simply, here's tangent of 45, opposite leg over adjacent leg, so 1 over 1, which is just 1. So sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. And tangent of 45 is 1. These are important to know, especially as you move further into trigonometry. We can use our triangle over here to find sine, cosine, tangent of 30 and 60. So we're really just looking at the one side, so we don't need this here. So let's take a look at this. 30 degrees, here's our 30-degree angle. Sine, let's write it out here again. So, ka, toa. O stands for opposite, H hypotenuse, A adjacent. So sine, opposite, over hypotenuse. 1/2. That doesn't simplify anymore, so we can just leave it like that. Oops. Cosine. Cosine of 30. Adjacent. So root 3, adjacent leg over hypotenuse. And then tangent is opposite 1 over adjacent, which is root 3. And again, you're not supposed to leave it like that, so multiply by root 3 over root 3, which ends up giving root 3 over 3. And sine of 60. So now we're looking at the 60-degree angle, opposite over hypotenuse, so root 3 over hypotenuse, which is 2. Cosine is adjacent over hypotenuse, so 1 over 2. And then tangent is opposite over adjacent, which is just root 3. So again, these 9 things, sine, cosine, and tangent of 30, 45, and 60 are important to know. They're actually going to be like multiplication tables. You just have them memorized. All right, last thing, state decimal approximations of the sine, cosine, and tangent of the angle formed by the ladder to the ground. Well, we can start with sine. Sine, it's angle A here, so sine of A is opposite, just 20 over the hypotenuse, which we do not have. So once again, we'll find it, and that's the hypotenuse in this case, so 6 squared plus 20 squared equals h squared. This is 36 plus 400 equals h squared, 436. We will, sorry about that. Get the calculator out here. We want the square root of 436, which is 20.8806. So we want the decimal approximation. Well, we can do 20 divided by 20.8806. That's 0.9578. Cosine of the angle. That's adjacent, so 6 over the 20.8806. Type that in your calculator. That is 0.2873. And finally, tangent is opposite over adjacent. So 20 divided by 6 is 3 1/3, 3.3333. And there you have it. So that's our introduction to trig ratios. You should be able to find any trig ratio of any right triangle if you're